So today's class, we are going to talk about three different laws, gas laws. The first law is nothing but Boyle's law. What do you mean by Boyle's law? Children, when we talk about Boyle's law, you should consider temperature is constant in this case. Understood? During constant temperature, what is the relation between pressure and volume that we are going to discuss here? So what do you mean by Boyle's law? Boyle's law means at constant temperature, the volume of a given mass of a dry gas is inversely proportional to its pressure. That means, children, you consider temperature as a constant, then the volume of a gas is inversely proportional to the pressure of that gas. That I can write it as V is inversely proportional to P. V is inversely proportional to P. Under what condition? Temperature is a constant. Now, children, I'm taking P to left side. Then what happened? PV is equal to a constant, right? Then it will become PV is equal to a constant. Now that constant I'll denote it as K. Hence I can write it as PV is equal to K. Understood? Now, children, you consider a particular mass occupies a volume V1 at a pressure P1 and another volume V2 at pressure P2. Then they are related by using Boyle's law. That is nothing but P1 V1 is equal to P2 V2 is equal to K. Now, another gas is there, you can write as P3 V3 also equal to K. Understood what you mean by Boyle's law? Is it okay? So children, listen carefully. Boyle's law means it is a law which is under one condition at constant temperature. Under constant temperature, what happens in case of volume and pressure of a gas? We are discussing. This relation is showed by Robert Boyle. That equation, we call it as Boyle's equation. And this law, we call it as Boyle's law. What is the statement of this law? At constant temperature, the volume of a given gas is directly inversely proportional to the pressure of the gas. That means V is inversely proportional to P. Now, P we are taking to left side, then the constant comes. That constant we call it as K. Therefore, we can write PV is equal to K. That is nothing but a constant. So, according to Boyle's law, we can write as P1 V1 is equal to P2 V2 is equal to K. Understood? Any doubts? Is it okay for everyone? Fine. So now listen carefully, children. We are going to do one numerical related to Boyle's law. Please listen carefully. A gas is allowed to expand at a constant temperature. Listen carefully. The gas is expanding at constant temperature. From that, you should understand this is nothing but they are expecting Boyle's law only because at constant temperature, right? So gas is allowed to expand at constant temperature from an initial volume of 300 milliliter to a final volume of 1800 ml. So initial volume means this one I can call it as V1 and this one I can call it as V2. At the end of the expansion, the pressure of the gas was found to be 1 atm. So at the end, the of the expansion, the pressure of the gas was found to be 1 atmosphere. So what do you mean by that? Final pressure is nothing but 1 atmosphere. Then they are asking what is the initial pressure? That is nothing but P1 they are asking. So children, you should write everything perfectly. So we understood V1 is nothing but 300 ml. V2 is nothing but 1800 ml. And the pressure P1 is nothing but we need to find, and the pressure P2, the final pressure they give it as 180. So children, how will you find that? At constant temperature, this is happening, right? So you can use at constant temperature. That means you can use Boyle's law, right? You can use Boyle's law equation. So what is Boyle's law equation? That is nothing but P1 V1 is equal to P2 V2. Am I right? So here, which term you should find? P term you should find. Therefore, P1 is equal to P1 is equal to P2 V. Sorry, P1 is equal to P2 V2 divided by V1. That means what is P2, children? 1 into what is V2? 1800 divided by 300, right? So 0 0 cancel. So pressure is nothing but you guys will get it as 18 by 3. So what is 18 by 3? 6. So what is the unit? atm atmosphere. So P1 is nothing but 6 atm. Understood? Is it okay? So children, when you guys are doing this type of numerical, you should check which particular term is constant. Based on that, you can understand which particular equation or which law you should introduce. So based on that, all the terms we mark, all the terms we got, we just wrote all the terms. Finally, we at constant temperature means that is nothing but Boyle's law. We substituted into that equation. I understood the initial pressure as 6 atm. Any doubts? Is it okay for everyone? So children, listen carefully. Now we are going to introduce second gas law, that is nothing but Charles law. So children, what do you mean by Boyle's law? Just revise. That is nothing but at constant pressure, at constant temperature, the volume is directly proportional to, isn't it? No. At constant temperature, the volume is inversely proportional to pressure. Am I right? Now, here in Charles' law, the constant term is nothing but pressure. At constant pressure, the volume of a gas is directly proportional to its absolute temperature. What do you mean by absolute temperature? That means Kelvin only it's showing. Understood? Unit is nothing but at Kelvin only. That is the meaning. So children, listen carefully. What do you mean by Charles' law? At constant pressure, the volume of a gas is directly proportional to its absolute temperature. So that means V is directly proportional to T. Hence, I'm taking T to left side. Then what happened? T will become the V divided by T, right? So V divided by T is nothing but a constant. That constant I can call it as K. Therefore, V by T is equal to K. Now, Charles' law equation we have just denoted as V1 T1 is equal to V2 T2. That is equal to constant. Any doubts? Listen carefully, children. Now we are going to do one numerical. So we don't know which law we should apply. So we'll try. So listen carefully. A given mass of a gas occupies a volume of 200 ml at 37 degrees Celsius. 200 ml. To what temperature must the gas be heated to make its final volume as 500 ml? So you should find the final temperature, right? So this is nothing but initial volume, that is V1. And 37 degrees Celsius is nothing but T1. And the final volume is given, that is nothing V2. You should find T2, right? And they given the gas remains, pressure of the gas remains constant. That shows it is nothing but Charles' law, right? It is nothing but Charles' law. Children, please write the equation of Charles' law. What is the equation of Charles' law? V1 T1 is equal to V2 by T2. After that, whatever things given also you should write. V1 is nothing but it's given it 200 ml. V2 is given that is nothing but 500 ml. Now temperature T1 is nothing but 37 degrees Celsius. T2 is a, so we need to find. Now children, here before doing Charles' law, you should remember this T1 you should convert into Kelvin. How can you convert into Kelvin? Convert temperature into Kelvin. How it possible, children? Nothing. What is the value at degrees Celsius? You just add with 273. That means temperature in Kelvin is equal to 273 plus degrees Celsius value. So we'll write it as 273 plus 37. You guys will get it as, what is the temperature? You guys will get it as 310 Kelvin you got, right? So T1 is nothing but 310 Kelvin. Now you can do the remaining numerical, right? So what is the equation? V1 T1 is equal to V2 T2. You should find T2, right? You should find T2. Then what happened? The equation will become, you just want write everything. V1 is nothing 200 divided V2 is nothing, sorry, T1 is nothing but 310. That is equal to V2 is nothing but 500 divided by T2. Okay. Therefore, you can write it as T2 is equal to V2 into T1 divided by V1. Am I right? Am I right? Therefore, the equation will be, you should find it as T2 is equal to, what is the equation, children? V2 T1 by V2 into T1 by V1. Right. So this equation will be, what all things you should substitute? V2 is nothing but 500 into 310 divided by 200 you should do. So this will give, how much value you guys will get down? This will give the value as 775 Kelvin you guys will get. Therefore, temperature will be 775 Kelvin. Now, children, you should convert. Now, convert Kelvin into degrees Celsius. For that, what you should do? Subtract 273 Kelvin. So what happens, children? 273 you should sum. Therefore, conversion of Kelvin to degrees Celsius. That means value minus 273. So you got here value as 775. That minus 273. You guys will get it as 502 degrees Celsius. Therefore, T2 is equal to 502 degrees Celsius. Any doubts? Is it okay? So children, what we done, you please revise once again. We understood already they given it as pressure of the gas remains constant. From that, we understood that we should opt Charles law, right? Now here, we understood what is V1, V2, T1 and T2. We understood we need to find T2. So we introduced Charles law. Based on Charles law, we found what is the equation for final temperature. That is nothing but V2 into T1 by V1. We substituted the value. We got the value in Kelvin scale. Now we need to convert that into degrees Celsius. Hence, we converted that to degrees Celsius. Just you subtracting the Kelvin value with degrees Celsius 273. It will give you the temperature, final temperature in degrees Celsius. Any doubts? Is it okay? Fine. Now, children, we are going to discuss about gas equation. So for this gas equation, for formulating gas equation, first we are considering Boyle's law equation. That is nothing but at constant temperature, volume is inversely proportional to pressure. And second equation we are considering is nothing but Charles equation. That is nothing but according to Charles law, at constant pressure, the volume is directly proportional to its temperature of the gas, right? Both the equation together we make the gas equation. Finally, we'll get it as P1 V1 by T1 is equal to P2 V2 by T2. Understood? Both the equation together we are formulating gas equation. That is nothing but P1 V1 by T1 is equal to P2 V2 by T2, which is equal to constant. Fine. Now we'll do a numerical. So listen carefully, children. We are going to do a numerical related to gas equation. So listen carefully. They given it as a gas occupies 700 ml at standard temperature and pressure. That is nothing but STP. Find the volume occupied by the gas when its pressure is 400 millimeter of mercury and its temperature is 15 degrees Celsius. So children, you should write what is P1, V1 and T1 and P2, V2, T2. So we understood from here P1 is nothing but 760 mm of mercury, and we understood V1 is equal to 700 ml. All those values are given, okay? Now T1 is nothing but 0 degrees Celsius. That means 273 Kelvin, right? 273 plus degrees Celsius value only, we are getting value in Kelvin, right? So here, this is nothing but 0 degrees Celsius. So we'll get it as 273 Kelvin. Now, what is P2? P2 is also given 400 mm of Hg, and it's V2 we need to find, right? And T2 is given, that is nothing but 15 degrees Celsius, that we should convert into Kelvin. That means 15 plus 273 will give you 288 Kelvin, right? So all the terms given. Now gas equation you should introduce. Gas equation is nothing but P1 V1 by T1 is equal to P2 V2 by T2. Am I right? Therefore, you write the value P1 is nothing but 760, V1 is nothing but 700, divided by T1 is nothing but 273. 273, which is equal to P2. What is P2? P2 is nothing but 400 into V2. We need to find divided by T2. T2 is nothing but 280 Kelvin. So this one we formulate, you'll get it as, when you solve this, you'll get it as V2 is equal to 1403 mm. By solving this, you'll get it as V2 is equal to 1403 mm. Understood? So this is the method we should introduce to find gas equation. Understood? By using gas equation, we can find pressure or volume or temperature. Either they will ask pressure, or they will ask volume, or they will ask temperature. But all the remaining values they will give. Only that particular value you should find. I hope children, you guys. So this is for today, children. So I hope you guys understood what I mean by Boyle's law. What is the equation of Boyle's law? Second one, we discussed Charles law. What is the equation of Charles law? Third one, gas equation. What is the equation of gas equation? And all the numericals. I hope you guys understood. So have a nice day, children. Bye.